welcome to this course named Curves and Surfaces. So, I have designed this course keeping in mind undergraduate students of Indian universities and who has a background in differential calculus of several variables. So, this course can be thought of as an extension of that. So, as extension of a calculus course or an introduction to the subject called differential geometry. So, the subject differential geometry deals with objects that are called manifolds. Simply speaking, I mean most elementary example of manifold will be a smooth curve in R2 or let us say a smooth surface in R3. The idea of manifold originates from the question that suppose a particle is travelling on plane or space with the restriction that from travelling from one point to another point, it will follow the shortest path. Shortest path, quote under quote, we will see what we mean by that. This idea comes from the laws of physics, laws of nature, or to say the conservation of energy, or say laws of thermodynamics. So, one needs to, so particles are supposed to follow the shortest path from travelling one point to another point. Now, our two-dimensional view of a three-dimensional view or planar view of world will say that the answer is simple, it will say just a particle will travel in a straight line. But if you think for a moment, suppose you have your earth here, which is ideally a sphere, and you want to travel from this point to a point here which is on the other part of the surface, which part we are not seeing on the board. Now, on the sphere you cannot draw a straight line, right. So, particle cannot move in a straight line, or for instance, if you have surface like this. So, this is your surface in R3, you just cannot travel in a straight line in such a surface. So, we have to travel in curve. In this course, however, I will strictly avoid the word manifold and always refer to two-dimensional curve or three-dimensional surface, and we will try to make sense in the course, mathematically make sense, that is the basic idea, to travel in a curve taking care of curvature. Now, most elementary example of a curve is a graph. So, f is a very nice function, let us say from an interval a b to r, and I look at the graph of f, so that will give me a curve in R2. So, this gives us a curve. Now, there is this very beautiful theorem, it is called implicit function theorem. I have written down the version from R2 to R. I will write down from R3 to R2 when needed, which says that every curve is locally, every smooth curve is locally a graph. So, before you are interested in this course, what I want that you get your implicit function theorem and its statement understood very nicely, and for the proof of this theorem you can consult any standard book, but very geometrical interpretation and very geometrically motivated proof is given in my earlier course, my earlier MOOC course, a differential calculus of several variables. So, we will start with background of implicit function theorem. Thank you.